Welcome to our chapter 2.6a and b characteristics of quadratics video. This one is actually going to be kind of a two-parter. There'll be a break partway in the middle, and I encourage you, it's going to be a little bit longer of a video, so if you need a break, take a break in the middle of it and come back to it once you're feeling a little more refreshed. But get your notebook out, be ready to take some notes, and we will get started. All right, so the lesson today, we're going to focus on exploring the properties of parabolas, talking about all the different characteristics and features. We're going to be able to find the maximum and minimum of quadratic functions. We're going to be able to graph quadratic functions using x-intercepts. We're going to talk about all the different forms our quadratics can be in, and we're going to be able to rewrite equations. That's actually going to be in a later video. All right, so our first key characteristic we're going to talk about is the vertex and axis of symmetry. So in our quadratic, every quadratic, whether it opens up or down, has these two key features, and these are really the features that everything is based on. The first one is called the vertex. The vertex is the point where the parabola turns around. So in this problem, our vertex is at the point 0, 0. Okay, it's the point where the parabola turns around. It's the maximum, the minimum, the highest point, the lowest point of the parabola. The other key feature we have shown here is the axis of symmetry. The axis of symmetry is this invisible line that divides our parabola into two equal halves. It cuts through the vertex. It cuts through the middle of the graph. And so if you know the vertex, you actually know the axis of symmetry. The axis of symmetry is just x equals the x value of the vertex. All right, so let's go ahead and graph this. This is what we learned in our last lesson, how to graph a quadratic in vertex form. And then we're going to identify the axis of symmetry and vertex. So from our last video, we learned that this -2 causes us to shift the vertex to the right 2, and this +5 causes us to shift the vertex up 5. So let's go ahead and let's start trying to graph this. Remember, we don't have to draw every single dash mark along the way. We'll say this right here is 2, this up here is 5, so here is our vertex, our first point right there. To get the next point of our quadratic, we're going to go ahead and plug in 0. So plugging in 0 looks like this: 0 minus 2 squared plus 5. Negative 2 squared, the negative's on the inside, so that's positive 4. 4 plus 5 is 9. So over 0, up 9. We'll put 9 right there. We can draw half of our parabola going up this way, and then we mirror image it on the other side. The reason we're allowed to do that is because of our vertex and axis of symmetry. So our vertex is this point right here. Your vertex is the point, in this case, 2, 5. And our axis of symmetry, you can draw it in if you want, if that helps you. You don't have to. It's this line that cuts through the vertex, and it cuts our parabola into two equal halves. So in this case, our axis of symmetry is x equals, and it's just whatever the x value of the vertex is. So our x value of our vertex right here is 2. Okay. All right, another form our quadratics can take is what's called standard form. So we talk about this in math too. Standard form, and this is probably the form that we're used to seeing it in when we're factoring and stuff, is ax squared plus bx plus c. So f of x equals ax squared plus bx plus c. When we graph in standard form, one thing that we'll notice is that this c value right here is always our y-intercept, and that's really nice. That's really handy to just get that y-intercept for free. And you can kind of see why. If I plug in 0, this piece is going to go away, this term. If I plug in 0, this term is going to go away. There's no variable here, so this is all that'll be left over, is your c value. So the c value of a quadratic in standard form is our y-intercept, 0, c. So you can see in this graph, this example right here, f of x equals x squared minus 3x minus 4. The y-intercept is going to be 0, negative 4. All right, so finding the vertex and axis of symmetry in standard form is a little more work. We have to use this formula right here. This is a really important formula. I'm going to put a star next to it. Make sure you copy it down so that way you can use it later. It's something you use a lot when we're in standard form here. What you need to do is you need to find the a, b, and c value of your quadratic. So our a value here is 1, our b value is -2, and our c value is 1. You can then plug it into this formula. So the formula works like this. You say x equals the opposite, or negative b, so negative, -2. b was already negative, so it's a negative. We'll see what happens with that in a second, over 2 times our a value, 2 times 1. Negative negative 2 becomes positive 2. 2 times 1 becomes 2. 2 over 2 becomes 1. This gives us x equals 1. This is our axis of symmetry. And remember what we said before, the axis of symmetry is just the x value from our vertex. 1, that was our x value from our vertex. To get our y value of our vertex, what we're going to do is we're going to plug in that x value. So we'll go ahead and we'll plug in that x value. We'll say 1 squared minus 2 times 1 plus 1. 1 squared is 1. Negative 2 times 1 is negative 2. That's negative 1 plus 1 is 0. So our vertex is 1 comma 0. All right, so to get your axis of symmetry, you use this formula right here. Negative your b value over 2 times your a value. Be careful if your b value, if it's already negative like it was here, the negative negative is going to become a positive. That gives you the x value of your vertex, the axis of symmetry. This is really nice. Axis of symmetry and vertex go hand in hand. X value of your vertex is your axis of symmetry. So that's your x value. You plug it back in, you get your y value. You can now write your vertex. And this is how we're going to graph our quadratic standard form. We're going to find the axis of symmetry. We're going to plot the vertex after we plug that in. We're going to plot the y-intercept, which is just the c value. So make yourself a little note right here. This is the c value. This we got to plug in x. And then if you need to plot any more points for some reason, you are more than welcome to do that. You can always plug in more values to get more points. So let's go ahead, let's do the first step. Let's find the axis of symmetry. Our a value is 2. A value is 2. Our b value is 4, and our c value is 3. So we'll go negative our b value, negative 4, over 2 times our a value, 2 times 2. That's negative 4 over 4 is negative 1. Okay, so our axis of symmetry is x equals negative 1. We can plug that negative 1 back in to get our vertex. So we have negative 1. We plug it back in. So that's going to be negative 1 squared times 2 plus 4 times negative 1 plus 3. You got to take a second to do this. Negative 1 squared is 1. Negative 1 squared is 1. Times 2 is 2. 4 times negative 1 is negative 4. So 2 and negative 4 make negative 2. Plus 3 is positive 1. So our vertex is at the point negative 1, 1. So we can go ahead and plot that. So remember, we don't have to draw super to scale. We just go, this is negative 1, up 1. We'll go ahead and put our first point right there. And then your second point you get for free. This one is easy. Plot the y-intercept. Well, the y-intercept is just the c value from our quadratic. So in this case, that is 3. So we'll go up and we'll say this is 3 and plot our other point. We can go from our vertex through that first point. And then remember, we can always just mirror image it on the other side of the axis of symmetry. So you're going to find your vertex using this formula, x equals negative b over 2a. That gives you your x value of your vertex. You plug it in. Be really careful with your order of operations here. You get your y value of your vertex and plot it. You plot the c value. So your c value of your quadratic right over here. Plot that. Draw one side of your parabola, draw the other, and you should be good to go. All right, so one more example, find the axis of symmetry, vertex, and y-intercept, and then graph the function. So we'll do all that process that we just did again. So first things first, x equals negative b over 2a. Our b value is negative 6, so we're going to get negative 6 over 2 times our a value is 1. So that's 6 over 2 is 3. So the x value of our vertex is 3. We still need to get the y value, so we're going to plug that in. 3 squared minus 6 times 3 minus 5. That's 9 minus 18 minus 5. Negative 9 minus 5 more is negative 14. All right, so this is definitely one graph that's going to be nice to sketch so we don't have to draw 14 little dash marks. We're going to say this is to the right 3, this is down negative 14, and we'll put our first point. Our next point we get for free. It's in the equation. It's just right up here. The c value is negative 5. That's our y-intercept. So I'll put another point right here. I'll say this is negative 5, and I'll put a point in there. I can draw one side of my parabola going through that point from the vertex, and then mirror image on the other side. Identify your key features, your axis of symmetry. We found that first. That was x equals 3. Your vertex, we found that second, was 3, negative 14. And your y-intercept is your c value. Y-intercept is 0, negative 5. All right, let's talk about opening direction real quick. Whether we're in standard form or whether we're in vertex form, the a value in front of the quadratic determines whether the parabola opens up or opens down. If the a value is positive, we open up. If the a value is negative, we open down. The way I like to think about this is a positive a is a smiley face, a negative a is a frowny face. It opens down. All right, the a value also affects whether the parabola is going to be narrower or wider. We don't actually have to worry about this too much. We don't have to worry about this as we're plotting it, because as we find our y-intercept, it's going to give us the shape for us. But if our a value is greater than 1, then we know it's going to be a narrower parabola. And if our a value is less than 1, right, if it's between 0 and 1, then it's going to be a wider parabola. If it's 1, then it's that sort of standard normal parabola, but greater than 1 makes us narrower. So bigger the number, the more narrow we are. Less than 1, the closer to 0 we are, the wider it is. And that goes for both the positive and the negative side of things. All right, with that opening up or down thing, we also get what's called a max or a min point, a max or a min point. The max or the min point is just the y value of the vertex. So when you do max and min points, you don't write a point, you just write the y value. So the minimum point here is negative 3. That is the minimum point there. The maximum point on this other one is positive 2. It's not y equals positive 2. It's not a point. It's just the y value of our vertex where it does the turnaround point. All right. We also can talk about when our parabola is increasing and decreasing because it makes this U shape. On one side of our vertex, it's going to be decreasing. On the other side, it's going to be increasing. All right, if we flip it upside down, it does the opposite. It increases first and then decreases. But in this example, it decreases and then increases. The point that it turns around is the axis of symmetry. So our axis of symmetry right here is x equals 0. So if you already know that, then you know that on one side of x equals 0, you're going to be decreasing. So when you're less than 0, you're going to be decreasing. And on one side, you're going to be increasing. Now, depending on whether it opens up or down, it flips which one of these, which side it's increasing on or decreasing on. But if you know your axis of symmetry, then you just have to change the symbol in between. So we look at the graph and we see, all right, first we're decreasing. So on the less than side, we're decreasing. And then we're increasing on the right. So on the greater than side of our axis of symmetry, we're increasing. So it's all related back to that axis of symmetry piece. You'll see a lot relates back to that vertex and axis of symmetry piece. All right, we've already talked about domain and range a bit. Your domain is your x values. So here our parabola goes forever to the right and forever to the left. So our domain for this graph is all real numbers. Your range is based on the max or the min. If your parabola opens down, it's a max. If a parabola opens up, it's a min. Remember, if it's a max, it's everything below because the arrows point down, so it's everything less because we're pointing down. If it's opening up, it's everything that points up, so it's greater than. So you would say the range is y is less than or equal to the max value, or y is greater than or equal to the min value. And remember, the max and the min are just the y value of the vertex. Remember, everything points back to the vertex and axis of symmetry. All right, so one last example here where we're identifying all these different things, a little bit of a practice thing, and then I'll have the first little break in the video, and if you need to take a break and look back at some of the stuff, I totally understand. That's probably a good idea. So first things first, our A, B, and C values, so we can find some stuff. Our A is 2, our B is -4, and our C is -1. We'll go ahead and find the axis of symmetry first. X equals -4 over 2 times 2. That becomes 4 over 4. X equals 1. So we know our axis of symmetry is x equals 1. All right, then we're going to plug that 1 back in. 2 times 1 squared minus 4 times 1 minus 1. 1 squared is 1 times 2 is 2. minus 4 times 1, so minus 4, that's negative 2 minus 1 more is negative 3. So the y value of our vertex is negative 3. The x value of our vertex is 1. So 1 comma negative 3. Just looking at the equation, we can see what else we can fill in. This is a positive 2 in front. So this tells us that our opening direction, since it's positive, is going to be up. Since it's opening up, that means we are going to have a minimum. Our minimum is just the y value of our vertex, which we found to be negative 3. And then we'll graph it first before we find the domain and the range. So let's go ahead and let's graph this. So I know I need to go to the right one, and I need to go up negative 3. Oops, sorry, not up negative 3, that's silly. Down negative 3. Okay, that's where my vertex point goes. And then since we're in standard form, we know that our y-intercept is just the c value here, so that's going to be negative 1. So we'll go ahead and make a mark at negative 1 and put a point there. We can draw one side of our parabola going this way, and then mirror image it on the other side, and it's opening up like we knew it would. Our minimum is down here at negative 3 like we knew it would. Vertex 1, negative 3, and our y-intercept is negative 1, even though it didn't ask us for that over here. Domain and range, we can go ahead and fill that information in. Domain is easy for quadratics. It's always all real numbers for quadratics. Our range is always going to be y is less than or y is greater than. Since it opens up, it's going to be y is greater than, and it's just the y value from our minimum. So it's y is greater than or equal to negative 3. All right, last but not least, our interval of increase and decrease, those are just going to take the axis of symmetry and change the equal sign to either a greater than or less than, and we can look at the picture to figure that out. So we have x and 1, x and 1. Let's see, when we draw this graph, we start decreasing first. So on the left side of 1, when we are less than 1, we are decreasing. So we say x is decreasing when it's less than 1. And then on the other side, that has to flip. So we would say it's increasing when x is greater than 1. So interval of increase and decrease, it should look just like your axis of symmetry, except 1 is a greater than and 1 is a less than. And so if you can find this axis of symmetry using the formula, you should be able to get these, or at least a good guess at these, pretty easily as well. All right, this is your time for a break. If you need to take a break now. Okay, the second part of this video should go a little bit faster, hopefully. Another part we need to worry about is the x-intercepts. If we have the x-intercepts of a quadratic, that is the point where they cross the x-axis. They're not always going to be these nice, convenient, beautiful points, but in certain situations they are. Negative 1, 0, and 4, 0 are our x-intercepts for this graph. All right, the x-intercepts are particularly useful when we're either writing a quadratic in what's called factored form or when we're given factored form. So this is our third form of quadratics. We now have standard form, we have vertex form, this is factored form. Factored form has the a value, does all the same stuff the a value does before, and then it has this x minus p, which is one of our x-intercepts, and x minus q, which is the other x-intercept. These are opposite like before. So if it says minus 5, the intercept is really at positive 5, or if it says plus 3, it's really at negative 3. It does that opposite thing. So again, a value determines whether it opens up or down, and if it's narrow or wide, and p and q help us find the x-intercepts of the parabola. So in this first graph right here, if we're just talking generic, since it opens up, we know a is a positive number. All right, we know a is a positive number, and we know p is going to be the x-intercept. Let's see, let's pick this one. So the x-intercept is 1, and q is going to be the x-intercept. Let's pick that one, is negative 3. Our vertex is this point down here. We don't really use vertex in factored form, but it's always a useful piece to find because it gives us our axis of symmetry, and that helps us find all this other stuff. Well, in this case, it's pretty easy to see what the vertex is, but it won't always be that easy. So to find your vertex, what you can always do is you can add your p, you can add your q, and you can divide by 2. What that does is that helps us find the middle of our x-intercepts, which is going to line up with the x value of our axis of symmetry, or the x value from our axis of symmetry and the x value of our vertex. So if you have that p plus that q divided by 2, you can then plug that in to get the y value. All right, So that's how we're going to do this. If we were to write this equation, it would look something like this. It would look something like y equals, a is positive, so in this case I think it's just a positive 1, so we won't write anything. And then you would write x minus 1, so it's the opposite of the positive 1, and x plus 3. If we wanted the vertex, we would say what's 1 plus negative 3? That's negative 2. Divided by 2 is negative 1. So the x value of our vertex is negative 1. Plug it back in to get the y value of our vertex. All right, so this just reiterates that right there. To get the x value of the vertex, we're going to take the p and the q, add them together, and divide by 2. We can plug that x value in to get the y value of our vertex, and that's how we're going to graph in this factored form. So our first step here, what we're going to do is we're going to identify and graph the x-intercepts. First things first, I have a minus 1 right here. So my first x-intercept is going to be at positive 1, 0. I also have a minus 3, so my next x-intercept is going to be at positive 3, 0. This negative 2 in front reminds me that the parabola is going to open down and be a little bit narrower, but we don't really do much more with it right now. I am then going to take that 1 and 3. I'm going to say my axis of symmetry equals 1 plus 3 divided by 2. That's 4 divided by 2 is 2. So I know the x value of my vertex is 2. I can then plug that 2 back into my original equation. So I'll go negative 2, 2 minus 1, 2 minus 3. So that's negative 2 times 1 times negative 1. That's negative 2 times negative 1 is positive 2. So my vertex is at the point 2, 2. All right, we have enough information now. We can start plotting all this stuff. So my first point is at 1, 0. So I'll go 1, 0. I'll put my first point right there. My second point is at 3, 0. So I'll go 3, and I'll put a point right there. These are my two x-intercepts. And then we did p plus q, so we did 1 plus 3 divided by 2 equals 2. That tells us that our axis of symmetry is going to go right through 2, so we got to put 2 on our number line right here. So we know that our vertex is somewhere above or below that line, right? Somewhere above or below that line. And then we plugged in that 2 to our equation right here. So I plugged in 2 for x, I plugged in 2 for x, I simplified it down, and I got the y value of my vertex was also 2. So 2, 2 is my vertex. I can put another point right here, and then I can finish drawing my parabola. If you also want to find the y-intercept, you can, or if it asks for it, you can, but in this case, we don't need to. Now let's double check real quick. We look at our a value. Our a value is negative 2, and yeah, look, our parabola is opening down, and it's a little narrower, so that should make sense. All right, so I think I have one last practice problem similar to what we just did. Let's start with our x-intercepts. So first x-intercept is going to be negative 1, 0. Opposite of the plus 1. Second x-intercept is going to be negative 5, 0, opposite of the plus 5. If you want to plot those right away, you can. So you go negative 1, put a point. You go negative 5, put a point. Now we know that the axis of symmetry is in the middle of that. So to find it, we say negative 1 plus negative 5 divided by 2. That's negative 6 over 2 is negative 3. So we know our axis of symmetry is x equals negative 3. So somewhere in the middle of that is going to be negative 3. So we now know that this is the middle of our parabola, so our vertex is somewhere above or below that spot. To get where it is, we plug that negative 3 back in. So we're going to say negative 3 plus 1 times negative 3 plus 5. We're plugging it back into the original equation. That's negative 2 times positive 2, which is negative 4. So my vertex is negative 3, negative 4. So negative 4 is somewhere down here, negative 4. I could go ahead and put a point right there, and then I can draw my parabola going through those points. Remember, you don't need the y-intercept. If you want the y-intercept, you can find it and plug it in and graph it, but we don't need it on this particular problem. So the special point we get here is we get the x-intercepts for free right off the bat from the equation. We get the axis of symmetry with this formula where we add those two x-intercepts together and divide by 2. That gives us the axis of symmetry. And then we get the vertex by plugging the axis of symmetry back in for x, getting the y value, and that gives us our vertex. So our x-intercepts are up here. Our axis of symmetry is right here. And our vertex is down here. All right, with that, you should be able to get started on the assignment for tonight. I'd be glad to answer any questions over Remind or email if you need. Reach out to me. Otherwise, I'll see you guys in our next live session, and I hope you have a great day.